Thank you very much, Peter. Thank you for this kind introduction, and thank you for having me at this very interesting conference. Today I'm going to talk about the data protection aspects of smart contracts as possible tools for automated decision making in the context of the GDPR, so the European Union's General Data Protection Regulation. And yeah, okay, my slides are going. So I think this is just very generally, previous speakers talked a lot about what blockchain is, but I'm going to talk about it a bit as well. So as you are already familiar with it, blockchain is one of the representatives of the so-called distributed ledger technologies, or DLTs. So it is a transactional database, as it was already mentioned by previous speakers, that is distributed over a network of multiple computers. So there's no central controlling entity or a server which is behind this whole structure, and it is based on algorithmic self-checking verifications. So the data is verified constantly by all of the nodes that are connected to the blockchain. So we can call the individual computers or representatives that are on the blockchain the nodes. Data and transactions are linked by groups. They are the so-called blocks in a chronological order to form a chain of blocks. So, and the next thing is about blockchain, which is very complicated. One are the smart contracts. So these are basically automated contracts based on blockchain technology. According to Nick Szabo, who, as far as I'm aware, was the first one who mentioned this concept, smart contracting, they are automatically implemented contracts, and blockchain technology is very good to have this kind of contracts to be implemented. And if the predetermined conditions are met, that means that the network or the computer network, the computer system fulfills automatically the contract. So basically these are smart contracts. So the performance, the security and unbreakability of the contracts are ensured by the computer network in which the parties prepared it. So in a blockchain-based environment, the nodes authenticate the process, the conditions, for example, the deadlines previously set out by the contracting parties, and the data to be processed in connection with it, for example, the identity of the parties, names, for example, bank account numbers, the amount, and when the predetermined conditions are met, that means then that the contract is fulfilled. So we do not have to rely on some kind of third party, for example, lawyer, to make the contract to fulfill the contract. So blockchain can be a very suitable solution, technical solution to develop a smart contract platform because they are self-executing automated applications embedded into blockchain. For example, Ethereum is one of the first blockchain-based networks that have this kind of smart contract feature built in. We can talk about deterministic and non-deterministic smart contracts. Deterministics are the smart contracts when the predefined digital contract that obtains all the necessary information from the database of the blockchain itself for which it is developed. And on the other hand, non-deterministic smart contracts when some information is required that appears outside the blockchain, so it's independent of it. In this case, the users must entrust the so-called oracle third party that has the information necessary for completion. The data transmitted by oracles can be interpretable information or unquestionable facts. For example, information to be interpreted comes into play when smart contract needs information that needs to be considered. For example, the fact is not clear and different experts are needed to decide the case, for example, determining the amount of insurance in an event of damage. Unquestionable facts, on the other hand, do not require separate interpretation as they are clear for all of the parties, for example, the value of the outside temperature. And to be not that general, I brought an example of a blockchain-based system in a smart city, which has smart contracts as well. So I've read this example, it's a hypothetical example, in a paper in 2020. So the network of light makes up the blockchain in a smart city, and each lamp has its own identity, a block on the network. And the lamps store data on their usage, performance, and downtime. So the maintainer, in this case, for example, the city council, can take advantage of this data and optimize the maintenance of the network. For example, an algorithm recommends more regular maintenance of the lamps that are used more frequently, etc. Now, this example, it's a very simple example, but we can also apply this kind of concept, hypothetical concept, to a system based on personal data as well, because, you know, street lamps doesn't have personal data, they are not natural persons, but yeah, a more complex smart contract-based, blockchain-based system can be developed as well. For example, the operation of smart meters by utility providers. So in this case, we can say that individual households can make up a network or form a network. So the individual households are the blocks in a blockchain-based network, and the data on water, gas, and electricity consumption can be recorded in the individual blocks about how the households use their consumption. So this can be sent real time by the network to the service providers, the gas provider, the electricity provider. They can be separate companies as well. So they can work together to maintain this kind of blockchain. AI and machine learning technologies can analyze the household consumption data, identify consumption patterns to optimize energy distribution between the consumers. So individual providers can also share identified data processing patterns with each other to synchronize their services for a better service distribution. So the history of consumption data is also recorded in the blocks and can be traced historically, and this can make the system more transparent and help to further develop the AI and machine learning techniques used to make the smart metering system work better. We can also design smart contract applications to this kind of network. They can process billing information, service data from households. For example, a smart contract application can track consumers' unique consumption data and issue smart bills, or even automatically initiate a financial transaction, for example, to the user's bank account or even crypto wallets if they want to make their purchases in cryptocurrencies. If it is necessary to collect data from third parties in order to carry out contractual transactions, then oracles can also be created in the system, for example, to take into account discounts for certain users if they have some kind of discount, for example. Now, going to the other big part of my presentation, what data protection aspects have these kind of smart contracting platforms, blockchain-based smart contract platforms? The European Data Protection Board, which consists all of the data protection authorities in the European Union, just last year issued a very, very detailed guidance of the data protection aspects, GDPR aspects of blockchain technologies. But back in 2018 and 2017, the French and the Hungarian Data Protection Authority issued guidances as well on the data protection aspects of blockchain. All of these guidances say that node operators are considered data controllers for the purposes of adding data and commanding transactional operations. So by the definitions of the GDPR, the data controllers are the main responsible parties to comply with the data protection law, or the GDPR. Cryptographic authentication of transactions ordered by others, these are data processing operations, and designing smart contract applications are also considered data processing operations in the terms of the GDPR as well. Now, what happens when automated means or automatic decision comes on the playground? GDPR has a special article, Article 22, which protects individuals against solely automated decisions. So they have kind of a right not to be subject to decisions based solely on automated decision. So this is triggered that there is no meaningful human review, and it has a significant impact on the data subject as well. So it has a very, very significant impact on our private lives. And in these cases, the GDPR said that the data subject have the right not to be subject to these decisions. So this is kind of basically, it has to be interpreted that this kind of operations, data processing operations, are forbidden. But on the other hand, if we look at smart contracts, in most of the cases, they are not that complex applications that has this kind of automated decision-making characteristic according to the GDPR. So in most cases, they just perform some kind of automated action based on an if-then logic. So on the other hand, the automated decision is a more complex, or it has a more kind of a bigger impact in our private life. And in these cases, basically artificial intelligence determines essential terms without any human input. I will talk about in detail in the following slides when considering cases when Article 22 can be applied to smart contract networks applications. So there are all exemptions about Article 23 of the GDPR. So these kind of systems which are automatically making decisions about our personal data and have a very, very serious impact in our private life can be developed and can be used for data processing in 3 cases: when there is a contractual necessity, so it is required to fulfill an agreement between subject and the controller, and everything is regulated in the contract, and of course the data subject can read it and decide it whether to sign it or not. The second one, if it is authorized by a union or member state law. And the third one, everyone's favorite legal ground in the GDPR, explicit consent of the data subject. So when it is based on the data subject specific consent or agreement. If Article 22 triggers and we have a proper legal ground for it, whether it's a contract or the consent of the data subject, or it is permitted by law, then the controllers must provide meaningful information on the logic to the data subject, which means not to open the black box, but to provide some kind of information to the data subject, what kind of system is his or her data processed, and so they have to explain the logic applied clearly and, for example, use graphics or test data to demonstrate expected outcomes to the users. And we also have this kind of right to human intervention and appeal. So if a system makes automatic decisions about our personal data, then the data controller must provide human intervention to that the decision. So a human reviewer must have power to overturn the machine if the data subject is, for example, not happy about the automated decision. Automation on the blockchain and the relationship with the GDPR. So, as I already mentioned about the synergy of blockchain, AI, and smart contracts, I have 2 approaches here. The first one, when AI analyzes data stored in the blockchain and tries to look for patterns in it. So the blockchain serves as a source of data, a training database in the process of machine learning. And the second approach is AI not only analyzes data, but also makes decisions, and they are recorded in the blockchain. So basically in the block history and the Merkle tree. As I already mentioned in my previous slides, automated action and automated decision are not the same terms. And in most of the cases, as far as I know, most smart contract applications are not on the level of automated decisions. So they are just making an automated action based on an if-then logic. So they are not reaching the complexness of automated individual decision. So smart contracts may not fall under Article 22 of the GDPR, as in many cases they only implement decisions made by humans in advance. So usually they are purely deterministic systems. At the same time, if the system makes independent decisions, for example, in the case of an energy network optimized by machine learning, as I already mentioned in my smart contract and smart grid example, then Article 22 of the GDPR may already apply. So we have to look very, very carefully on the system, how smart contracts are embedded in the system, how they are working. Do they reach the complexness and level that we can talk about an automated decision-making system? So this is just a very simple figure about how to integrate machine learning systems into blockchain technology. So we have a training database, a blockchain-based training database. It can be personal data. But of course, when it is personal data, then we have to apply the GDPR. And we have some kind of algorithm that searches for patterns and the execution of about automated decisions. So the distinction that smart contracts are commands, AI provides autonomy from static instructions to dynamic predictive models. So what are my conclusions? Smart contracts efficiently automate and secure contractual relationships, typically using blockchain as a highly secure and distributed technical infrastructure. But it has to be highlighted that most smart contracts are not AI systems, as they usually execute predefined actions and do not make autonomous data-driven decisions. We can combine, on the other hand, smart contracts with machine learning. It enables then complex automated decision-making systems that may significantly affect users and consumers' rights. And if this is the case, but only if this is the case, then data protection compliance becomes very, very critical in such systems, and the applicability of Article 22 of the GDPR must be assessed with transparency and explainability as key requirements. And if you are more interested in the topic, then I recommend you this book and a chapter which was written by me. It has the same title as my presentation, The Data Protection Issues of Smart Contracts as Possible Tools for Automated Decision-Making. It was published by Springer last year, and it was edited by Kitty Mezei and Marton Varjú, research fellows of ELTE Center for Social Sciences. So thank you very much for your attention. That was my presentation about smart contracts and relationship with the GDPR.